Hello. Today we'll uh, look at into a problem to solve the to find the various parameters of a transmission line using Smith chart. Okay, and the question is, if the transmission line has a characteristic impedance that is Z naught equal to 200 ohm, and it is terminated in a load which is ZR equal to 100 plus J 100, and assume the total length of the line is 1.2 lambda. Using Smith chart, find A VSWR, B reflection coefficient, C input impedance, and finally D position of Vmax and V minimum from load. So the first step to solve this problem is find the normalized impedance. The given value is ZR, which is 100 plus J 100, and Z naught is equal to 200. So normalize the impedance, which will give you Z small letter r, which is 100 plus J 100 divided by 200, and the obtained value is 0.5 plus J 0.5. So this is the value of load impedance, normalized load impedance we are going to plot in Smith chart. Okay, let us have a look at into Smith chart after plotting this. So our point that we are going to plot is 0.5 plus J 0.5. So this is the Smith chart. So in this Smith chart, so if you look at the x-axis, horizontal axis, you can see the various values like 0.1, 2, 3, 4, 5. So this is the resistance circle, 0.5 circle in Smith chart, and the reactance value is again plus 0.5. So you can find 0.5 here, this is reactance value. So these two circles will come together at this point. Let the point be P. So this is 0.5 plus J 0.5. Load point is at R. And the center of the Smith chart is, let it be O. And remember one thing, if the value is 0.5 minus J 0.5, your point will be at the lower half of the Smith chart at this point. Since this is positive, it is in the upper half. So the next step to solve this problem is, with OP as radius, draw a circle with OP as radius. So with OP as radius, I have drawn a circle. So this circle is also called as S circle. S circle. Okay. So this circle will cut the x-axis at 2 points. The right point will give you the value of VSWR, which is equal to 2.6. So this is the two circle with the value of 2, 2.2, 2.4 and 2.6. So VSWR value is 2.6. Also, the same point is termed as V maximum, and the left corner is termed as V minimum. Okay, so the method to find VSWR is, with OP as radius, draw a circle. That radius, that circle will cut the x-axis at right end and left end. The right end value will give you the VSWR. And one more method is, with the same radius OP, come to the bottom of the sheet where you can find the SWR scale. Okay, so keep it at the center of the scale and draw an arc in SWR scale. So you can see this exactly, it is giving VSWR is equal to 2.6. Okay, so you can use either drawing a circle and find the point where the circle is crossing at the right x-axis, or with the same radius you come to the bottom of this scale where you have SWR scale, draw an arc, it will give you the exact VSWR value. So now question, finding VSWR is done, that is 2.6. So we'll move to reflection coefficient, second question. So to find the reflection coefficient, again with the same radius, with OP as radius, come to the bottom of this sheet where you have reflection coefficient scale. You can see at the bottom reflection coefficient in terms of voltage or current. So with the same radius, from the center of the scale you draw an arc in the reflection coefficient scale, that will give you a exact value of reflection coefficient. So this is 0.44244. So reflection coefficient gamma is equal to 0.44. That's the value we are getting. This is the magnitude of reflection coefficient. Okay, now how will you find the phase angle of the reflection coefficient? So come to the top of this sheet with O, with the from the center O along the point P, draw a line to the outer circle. From the center along P, draw a line to the outer circle. So what happens is, at the right corner of the sheet you can see that angle of reflection coefficient in degrees. So this circle will give you the scale which is the angle of reflection coefficient. So this line from O along P will cut the outer circle which is the angle of reflection coefficient at some point. So this is exactly at this point it is cutting at the reflection coefficient angle. So it is 117 degrees. Okay, so final value of reflection coefficient is equal to 0.44, which is the magnitude, and the angle is 117 degrees. So we have finished two values, one is VSWR, another one is reflection coefficient, both magnitude and phase angle. This is one method of finding reflection coefficient. And another method is, this is also a simple one. From the center you have we have already drawn an S circle. So find the radius of the S circle in with your scale. Find the radius. So if you find the radius of the circle, you can see that it is around 3.9 centimeter. In a circle 3.9 centimeter. Okay, and also you find the radius of the outer circle from the center. So we'll get a value which is equal to 7.8 centimeter. So if you divide this value 3.9 by 7.9, you should get a value which is approximately equal to 0.44, which is the magnitude of reflection coefficient. So this is the second method of finding a magnitude of reflection coefficient. So this is done. Value is 0.44, angle 117 degrees. And third one is input impedance. How will you find the input impedance? In the question, the total length of the line is given as 1.2 lambda, and we know the load impedance. That's all. So this is the load point. So from this load point, we have to move towards a generator. So if you draw a circuit, sorry, ZR, this is Z in. So total length of the line is 1.2 lambda. So we know the point where the load exists, and we have to move in the opposite direction towards generator for a distance of 1.2 lambda. So you will end up with the input impedance. So from this point, if you move one full complete rotation, you will cover 1 point, lambda by 2, that is 0.5 lambda, half wavelength. Again, you go for another full circle, you will cover 1 lambda. Okay, so after 1 lambda you will reach the same point. So from 1 lambda you have to move for a distance of 0.2 lambda in clockwise direction. Okay, so this is the location of your load point. So the in terms of wavelength it shows like 0.088 lambda at the outer circle. So how will you find the input circle? Input impedance from this point move for a distance of 0.2 lambda. So assume this point as 0 and each and every point you move like 0.01, 0.02, 0.03, okay, for 0.2 lambda. 0.01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 0.10, 0.11, 12, 13, 14, 15, 16, 17, 18, 19, 2. Okay, so this is the point which gives after we move for a distance of 0.2 lambda. Then from the center of the Smith chart, from the center, connect this point. So that line will cut the S circle at some point. That will give you the input impedance. That is exactly 2 minus J. Okay, so the input impedance is 2 minus J. Normalized input impedance is 2 minus J. So how will you find the actual input impedance? Normalized input impedance equal to 2 minus J. So we know the characteristic impedance is equal to 200. Okay, as per the question it is 200. So for normalizing we have divided the value by 200. So to get the actual value, multiply it with 200. So 400 minus J 200 is the actual input impedance. Okay, so the answer is 400 minus J 200 ohms. And the final question, position of Vmax and Vmin from load. So we know the location of V maximum and V minimum. This is V maximum, this is V minimum. So this is the location of our load. So what we have to do is find the distance from this load up to V maximum and V minimum. Okay, so the point where our load is located is 0.088 lambda. Okay, so from this point the V maximum is located at 0.25 lambda. So if you take the difference between these 2 points, you will get the distance between load and V maximum. Okay, that is 0.25 minus 0.088 lambda. So your answer is approximately 0.162 lambda. Okay, this is the distance of or position of V maximum from load. And what about V minimum? V minimum is at the opposite end. So from V maximum, V minimum is at a distance of 0.25 lambda. So the calculation is a bit easy. Add 0.25 lambda along with 0.162 lambda. That is 0.25 plus 0.162 lambda equal to 0.412 lambda. So this is the position of V maximum from load and this is the position of V minimum from the load. That's all. Thank you.